Hey guys, it's Andre from High Performance Academy. Welcome along to another one of our webinars. This week we're going to be talking about engine block preparation, one of the keys when it comes to building any performance engine. So as you can obviously see, we've got a couple of engine blocks already set up here. I'm going to go through some of the aspects that we can be looking for, some of the things you need to keep in mind, how you can work with a machinist in order to get the best possible results, and what you need to be doing when you're actually doing your final assembly of the engine. Before we get into that though, we'll just cover off a few things that have been going on over the last weekend. For those who maybe have been hiding under a rock or haven't been following us for too long, you may not realize that my old shop car is fairly well known. DOCILE, it's a Mitsubishi Lancer EVO III that held the world record at the time it was retired for the fastest Mitsubishi EVO four-wheel drive. Bit of a mouthful, but that's what it did. We'll jump across to my laptop screen. I'll just quickly show you the car. So that's it there. A car that was Japanese domestic market, so particularly for a lot of the people watching from the US, this isn't a car that ever came out over there, unfortunately. We built this basically from a street car. Initially we built it to run 10-second quarter miles, and it was street legal at the time. I think it ran a 1088 on its second ever pass down the drag strip, which was also coincidentally my second ever trip down the drag strip. So at that point I kind of ticked off what we'd aimed to do with the car. So as with drag racing, it kind of always escalates pretty quickly, and by the time we ended up retiring the car, this is kind of what it looked like. So obviously got pretty serious, no longer a street car. Cut the front end off the car for two reasons. One was to save weight. Turned out that actually didn't really save that much weight. Pretty disappointing at the point where we finished cutting the front of the chassis off and removed it. It really probably only weighed about 18 or 19 kilograms. There wasn't a lot of weight in it. We added a reasonable amount back in with the chromoly tube frame chassis that you can see there. It's all tied into the cage, so it's nice and strong. We actually saved more weight by removing the factory cross member, the factory subframe, than the front of the car itself. So that was quite surprising. But the other reason we did this, which is a little hard to see in these photos, is we also converted from McPherson strut to an equal length parallel double wishbone front suspension. The idea behind this was to make sure that we had zero camber change through the bump and rebound travel. Obviously with a drag car, we don't really care about going around corners. If you're going around a corner, you've done something wrong, you've gotten lost. It's all in a straight line, and what we want to do is make sure that during the bump and rebound travel, we've got as much of that contact patch of the tyre on the track as possible. So that's what we did there. This is sort of another angle of it. So it became pretty iconic, this car, and at the moment it is sitting in Highlands Motorsport Park's museum, about 45 minutes up the road from us here in Queenstown, and gathering dust, maybe stopping the dust from getting on the floor underneath the car. And it's sat there ever since we moved to Queenstown about 5.5 years ago now. It's been a bit of a tricky one knowing what to do with it. I've still got a bit of an interest in drag racing, but unfortunately now being in Queenstown, we are literally the opposite end of New Zealand from the only really good quality drag strip that is in the country, Mary, which is just out of Auckland. That is probably about a 20+ hour trip, so not that excited about road tripping up to Mary every second weekend to go drag racing over summer like we used to when I lived in Wellington, which was only about 6 hours away. The other aspect though is we've now got a car that's got a lot of history behind it. It's got a lot of people that followed the car during the time we were racing it, and it seemed like a bit of a waste to sell it basically for what it's worth as a rolling chassis, because it has no engine and gearbox in it at the moment. It really isn't worth a lot of money, and for the sort of money that I'd likely get back for it, just really didn't seem like it was worth letting it go. Particularly when we look at the front clip, which is one-piece carbon fibre. There's around about $5,000 worth of work went into that front clip. It's got a set of custom Simmons wheels, which were pretty pricey, and it's got about $15,000 worth of aluminium body custom valved Coney suspension, purposely built for drag racing. So that and the chromoly custom front end as well as cage, yeah, it just didn't really seem right to let it go. We've been sort of struggling with what to do with it, so we have been constantly having requests to add some engine building content on the 4G63 platform. Obviously, with my experience with this car as well as the hordes of other 4G63s we modified and built through my old shop, the 4G63 probably would be one of the engines I know inside out, back to front. I know their strengths, their weaknesses, and what you need to do. So it only seemed fitting that we actually knuckled down and did something with this car. So we are going to be bringing it back. Although, like I say, probably aren't going to be aiming for any world records or going down the drag strip anytime soon. But even just building it up so we can do, first of all, a high power 4G63 engine building worked example that'll go into our worked example library in our practical engine building course, as well as doing some content around tuning high powered methanol drag engines, which again we do get requests from. That'll probably be sufficient. Back in its heyday, this engine made 1166 wheel horsepower, running about 54 psi of boost on methanol fuel. We revved it to 10,500 RPM, occasionally closer to 11 on the drag strip. These days, those numbers really aren't that impressive. There's cars like Boost and Performance's Red Demon, I think, are closer to about 1800 flywheel horsepower. Of course, there's the likes of Colin Wilshire, over 2000 horsepower, albeit with a billet block. And we're not chasing those sort of numbers. Basically, we're looking at an engine combination that should be able to put down somewhere between maybe 11 and 1200 wheel horsepower on our mainline Pro Hub dyno. That'll probably be enough to keep me pretty happy, and if we do get a chance to put that down the track sometime in the future, that'll also be pretty exciting. So what we're trying to do with it, we're going to be rebuilding it much like it was. We've actually still got some of the parts, including I've got here behind me the original exhaust manifold that was on this car. I feel this is still even probably 15 years on from when it was first built. Bit of a work of art. This is built by Jono Climo from Performance Metalworks, a company that unfortunately is no longer in existence, and that used a V-band flange to bolt up the T51R SPL HKS turbo. Jono was also responsible for the majority of the other fab work on the car, and despite him moving on with a different industry now, I still rate him as probably one of the best fabricators in the whole of the country, maybe even on a level footing with some of the best in the world. Now, when we built this car, the turbo technology, definitely safe to say, isn't where, or wasn't where it is now. We've seen some massive advances, particularly over the last decade, in turbo technology. And while this particular engine made plenty of power, the power band did suffer. With that T51R turbo on it, we weren't seeing full boost until a touch over 7,500 RPM. So it was actually only really coming on at about the point where a conventional 4G63 road car engine's hitting the rev limiter, and that's why we had to rev it to 10.5, 11,000 RPM to get a usable power band. Even then, that's quite tricky using the PPG 4-speed dog engagement gearbox, even with clutchless shifting and a very short ignition cut for the gear shift event. You inevitably end up losing quite a bit of boost on the gear shift. So we're really excited in particular to put to the test some of the new advances in turbos that have come out. Not 100% sure on exactly which direction we're going to go at the moment. The Zonarotor is one that is on the top of my list, but yeah, we'll see exactly where we get to once that's built. At the moment, we've just been sourcing some parts for the build. While obviously billet blocks are the way to go now, and they've actually come down to a point where they're actually pretty cost effective. That's not what we want to do with this build, so we are going to be sticking to a cast block, and I think this is probably more relevant to a lot of the people out there who are building up these engines. So these days though, finding good condition stock bore size 4G63s is actually pretty difficult, and you can't buy brand new blocks from Mitsubishi, which is a bit unfortunate. So we've sourced 3 blocks and 3 cylinder heads. We figure because they are quite difficult to get, it's a good idea to get a little bit of a stockpile, because unfortunately when you are pushing engines to this sort of level, sometimes things don't end up working out the way you'd hope, so always good to have a few spares. In short, the build specs that we're going with here, we're going to be using a 2 litre crank still, so still the 88mm stroke crank. I like the 88mm stroke crank because with these engines we do end up revving them so high. So while there are 2.2 and 2.3 stroker cranks, the 94 and 100mm stroke crankshafts, piston speed and also rod to stroke ratio do tend to suffer. In terms of the rod to stroke ratio, what we're actually going to be doing is building what's referred to as a long rod 2-litre engine. So we're still retaining the 88mm stroke, but what we end up doing is putting a 156mm con rod in it, so that's 6mm longer than stock. Now, probably you're thinking, well, how's that going to work? The piston's going to stick out the top of the bore. How that's dealt with is the compression height of the piston, essentially where the wrist pin is located in the piston relative to the deck surface of the piston. That just gets reduced and basically moved up 6mm. So this gives us a slight improvement in our rod to stroke ratio, and again, that's helpful, particularly when we're looking at punching out 11,000 RPM. With the fact that it will be running on methanol fuel, we will be raising the compression ratio a little bit. Generally with the engines that I had in my drag program, we ran a flat top or a very slight dome, generally around about 10.5 to 1 compression, and as high as 11.5 to 1, which isn't a problem on methanol fuel, but you start to see diminishing returns with that increase in compression ratio at some point. The rest of the engine will be pretty conventional. We're going to be running a CNC ported cylinder head with oversized valves, a set of reasonably aggressive cams from Calford, up around the 300 degree duration, and pretty much sort of learning from what we had back in the day. Actually going slightly smaller in the cam profile as well, which hopefully will help with the newer technology turbo to give us that wider power band as well. So this is a project that is only getting started, so we're probably going to be building this up over the next 12 months. So obviously, if you're following our vlog, you'll be able to learn a little bit more as we get stuck in on our vlog. Also, moving on, update with our FD3S project. And I've been talking about this over the last couple of weeks, and that's because it's been spending a fair bit of time on our dyno while we've been ironing out a few bugs, making sure everything was working exactly how we'd expected. And if we jump across to my laptop screen again, this is currently the final result in terms of power. So 422 horsepower at the wheels, or 315 kilowatts if you prefer to work that way. This is run on just a touch under 15 psi, so that reference line there that I'm just marking in, that's 15 psi, so we're sitting at about 14, maybe just bumping into 15 psi through that run. I only actually wanted to get 400 horsepower out of it, given it is a completely stock, basically unknown origin 13B Series 7 short block, so push it too far and obviously you can expect some problems. So given this, the boost is relatively low, we've got a pretty conservative tune-up in it, so I'm not expecting that that's going to be problematic. But even then, having said that, 420 horsepower at the wheels is a fair chunk of power to be getting to the ground through normal street tyres. What we probably will end up doing is dropping to a softer wastegate spring so that we can at least pull our boost down in the lower gears and then step that up as we get into maybe third or fourth gear, and we can actually put all of that power to the ground. Last week I was talking a little bit about the boost control strategy, and we'll just head across first of all to our Mega Log Viewer. This is a slightly modified version of what I was showing last week, where we've got down the bottom here this yellow plot, which we can see is our wastegate position. It still isn't scaled, it doesn't, the numbers are pretty meaningless, but what I was showing last week was basically the point here where we could see that the wastegate starts to open back at that point before we actually got to our peak boost. So again, if we come back over here, we can see that the boost sort of is a bit lazy to come up there. What we want really is our boost to sort of do something a bit more like this, and then reach that flat line all the way through. That's ideally what we'd like, and that's going to end up increasing our power band, sort of something a bit like this. Now, there are a couple of problems with this. One is that electronic boost control can be a little bit tricky when we are trying to get down to just about no duty cycle. It probably doesn't sound too helpful, so I'll explain a little bit more. When we're running one of the 3-port or 4-port boost control solenoids, they only really start working somewhere around about 10 to 15% duty cycle, and likewise once you go above about 85 to 90%, they're basically the same as being wide open, fully open. So you've actually got a range within the 0 to 100% duty cycle range where you've actually got linear control. It's actually not too dissimilar to a fuel injector, and you can actually test this if you've got an ECU that allows you to do a pulse width modulated output test. You've got the engine switched off so it's not making any noise. What you can do is pulse that solenoid, and as you vary the duty cycle, once you get down past about 10%, maybe 15% depending on the solenoid, you'll find that you can physically hear it stop clicking, and likewise at very high duty cycles as well, it does exactly the same thing. So this is problematic because we've sort of got that step from 0 up to, let's say, 10%, where we're not really getting any control. So it's not, doesn't give us really good resolution down there. So this means it can be a little bit tricky to get really good control of the boost when we're running right on the bottom of that wastegate duty cycle limit. This goes away and doesn't become a problem. Let's say we had a 10 psi spring in the wastegates and we wanted to run 15 psi. This gets us off that duty cycle floor and we've got a lot more control. That being said, this is essentially what we did here. It's a bit of a rough and ready test, but you can see exactly what I'm talking about. So our yellow plot here is with just pneumatic control on the wastegate, no electronic intervention, and we can see by using a little bit of wastegate duty cycle we're bringing that in early, and you can see exactly the problem I'm talking about here. Because of that duty cycle where it drops out, we actually see the boost drop down and then it starts to come back up again. And looking at exactly what's going on there in Mega Log Viewer, we can see this green plot here. This is our boost, and you can see again that slight dip. So again, probably a limit to what we can do with that. The important thing to note here, which I personally think is pretty impressive for this 8474 BorgWarner EFR turbo, is you probably struggle to see the numbers there. That's all in, albeit only 14 psi. That's all in by 3,700 RPM. So what that's going to mean is on the street, it's going to have a really nice wide power band. It doesn't really give away a lot of bottom end, even compared to the stock twin turbo system. And of course, once you're above 3,700, it just keeps on going. So pretty impressive how that's all working. You can see even at that point there, we still have got the wastegate moving off its seat just prior to that, but we can't keep it 100% closed, otherwise we're going to see an overboost. If we just head over to Eugene, the Adaptronic software, and we'll come into our tuning in air, and we'll have a quick look at our duty cycle map for our wastegate. So this is set up three-dimensional. I've got TPS on the load axis here. So this is again a rough and ready test here, where you can see what I've done here. We've got numbers up to 3,250 RPM of 22% wastegate duty cycle. So we're not really pushing it very hard. And then as soon as we get up to 3.5, we were just about up to our target. We're starting to drop that down. We've got 19%, 16%, and then 12%. And then of course from 4.5 up, really there's no need or no point in having numbers in here, because we're down below that point where the wastegate will actually, the wastegate solenoid can really operate. Another thing to just bear in mind here as well, the options on the market there for wastegate solenoids is the conventional 3-port, still the most popular, 4-port as well, which is a little bit trickier and tends to give you a wider span from the wastegate spring pressure up to the maximum boost that you can run at 100% duty cycle. And we went with the 4-port for the reason that we were expecting to run softer springs in the wastegate, and again that'll give us that range, given that at some point we're probably going to put a built engine in it, probably run on E85 and push this engine considerably harder than we can now, and that's going to give us the ability to run somewhere between maybe 10 and maybe 25, 30 psi. We'll see how brave we're feeling when it comes to it. So the 4-port solenoid works well there. What we do need to bear in mind though with the 4-port solenoids is that they do tend to give a coarser response in terms of each percent duty cycle that we put into the table. So compared to a 3-port, you're going to get a bigger increase for every 1% 10% duty cycle you add in. On that note, we're basically finished off with the tune there. Just did some cold start testing on it this morning. We're in the middle of winter here in Queenstown, regularly getting down below 0 with snow on the ground, so it was a good chance to put that to the test. And good news is that's all working quite nicely as well. So later this week we're hoping to get started filming the Adaptronic worked example for our practical standalone tuning course. It's going to be perfect for any rotary enthusiasts out there. I know that a lot of people are scared of tuning rotary engines, and yes, there are some intricacies you do need to keep in mind when compared to tuning piston engines, but hopefully that worked example is going to show you exactly what you need to know. Now on that note as well, in terms of new courses, for those who aren't aware, we have partnered with Nigel Petrie from Engineered to Slide, and we have set up ETS Fab School. So this is an online fabrication school, and this was launched back in December last year. At the time we launched that course, platform, we had one course online, which was the Motorsport Fabrication Fundamentals. Nigel has been really busy working away on his practical TIG welding course. I'll jump across to my laptop screen, and that course released earlier this week, or actually end of last week I think. Perfect for anyone who wants to learn more about fabrication, so you can head to etsfab.com/courses to take a look at that. So Nigel talks you through the process of TIG welding. You'll learn how the TIG welder works, all of the parts of the TIG welder, and really importantly there as well, if you are in the market for a TIG welder, there is a TIG buyers module in there, so everything you need to know about choosing a TIG welder is going to suit your requirements, your electrical supply in your workshop or garage, and also making sure that you're purchasing something that's going to be able to support all of the materials and different thicknesses that you're going to want to weld. A lot of information in that course as well on a subject that might seem a little bit boring on face value, PPE or personal protective equipment. However, it's always important to make sure that you are safe when you're doing anything dangerous like welding. Obviously there's a lot of heat involved with this, and also UV radiation that is emitted from the TIG arc, which can end up burning your skin, so you'll learn what you need to keep yourself safe. On top of that as well, there is a simple 6-step process that you can apply to TIG welding any material. In particular there, Nigel also goes through all of the requirements of setting up your TIG welder, as well as your materials for welding different types of materials such as aluminium, stainless steel, mild steel, chromoly, even titanium. You'll learn about back purging as well, and how to go about that. Really important on some of the more reactive materials such as titanium, essential with titanium. Also pretty important if you want a good result with stainless steel with the inside of the weld there. So that course is available for $199 US. Alternatively, there is a payment plan option. You can break that down into 8 payments of just under $25 a week. You'll get instant access to all of that course material. And if it's all looking a little bit familiar and a little bit like the HPA platform, no big surprises, it is. So you should be pretty familiar if you're already an HPA member. So again, if you're interested in learning more about that, etsfab.com/courses. Right, also wanted to just quickly touch on an Instagram that I put up last week, which is a shot. It's a little bit tight, a little bit hard to see, but this is a shot of a Mercedes DTM race car, 2018 Mercedes AMG DTM race car. And this little guy here is something that caught my attention. And it's a quick disconnect fitting, a dry brake fitting on the fuel line, where the fuel line comes from the chassis and runs through to the engine. And what it's designed to do, we actually talked to the engineers about it because I was quite intrigued by it, is designed so that in the event of a serious impact where the engine is actually ripped out of the chassis, obviously not something we want to happen, but it can happen. This is designed to actually break away, and it's a dry brake fitting, so it stops fuel leaking, and this is just designed to help reduce the chance of a massive fire in the event of a serious accident. So quite nice to see the extent that the engineers go to in designing these cars to make sure that they're as safe as possible when they are going as fast as they are. Obviously, keeping the driver safe and healthy is pretty important. Lastly as well, or second to last for today, this is our latest video which launched today. If you haven't checked it out, you can watch this on our YouTube channel. This is a video, a tech tour that we shot with Dom Rigoli from Tony Rigoli Performance over in Australia when we visited Sydney Jamboree, and Dom is intent on taking the fight to the Toyota 2JZ, which has been the dominant force in import drag racing. Not only that, at the moment Dom's pretty keen on keeping a cast iron block Nissan RB26. Well, to be fair, it is actually the diesel variant, the RD engine. So we learn a little bit about the pros and cons here of the RB versus the 2JZ. It's not an argument that I want to weigh in too much on. There's definitely some very vocal advocates in both camps, but fair to say that at this point the 2JZ is reigning supreme. So Dom's pretty keen on changing the status quo there. So this is a full tube frame chassis Nissan 350Z. They've got that cast iron block in. I think it's at the moment it's making about 2,100 wheel horsepower on a Pro Hub dyno, and it's run as quick as a 633. Can't quite remember the mile an hour, but that's all inside of that video. Unfortunately, this event did get rained out, so we didn't actually get a chance to get too much track footage. I think we got a couple of shots of some test passes on the practice day, but the actual race day, yeah, unfortunately it was rained out. If you're interested in learning a little bit more about that car, head along and check it out. Also, Dom and the Rigoli Performance team are kind of legends in the import performance area. This is a company that I looked up to, and I was watching their endeavours back when I was first starting my own shop. So particularly if you're not from Australia or New Zealand, probably a company that you haven't heard of before, go and check that out while you are there. If you like that video, give it a thumbs up. If you've got questions, ask them in the comments, and if you haven't already subscribed, make sure you do so. That way you won't miss out on any future videos. Lastly for today, I do mean lastly this time, we are still running our AEM CD7 dash giveaway. So this is a carbon fiber surrounded 7-inch full color dash. It can communicate with obviously the AEM range of ECUs nice and easily, but don't let that put you off. It also will communicate with just about any aftermarket standalone ECU as well as late model factory ECUs via CAN. So really easy to get data into this from a wide range of products. This is also the top of the line logging model, so it's got onboard logging as well as a 20 Hz GPS. Now, not only are we including the AEM CD7 dash, you will also get our full suite of tuning courses. Not specifically that you need to tune a dash, but kind of goes hand in hand with aftermarket ECUs and tuning. That giveaway has only got a few more days to run, so I'll get Luke to drop a link in the comments that you can click on to get your name in there. There's a few other tasks that you can complete as well to get yourself a few more chances to win. Absolutely no cost and no risk of getting involved, so why not have a crack? And if you are wondering, yes, we will ship that anywhere in the world, so it doesn't matter whereabouts you're watching from. Alright, that brings our pre-show to an end. Thanks for watching. Give us a couple of moments here and we'll get started with our webinar. If you like that video, make sure you give it a thumbs up, and if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.